Hey everyone, and welcome back to the channel. Today, we're diving into one of the biggest, most mind-boggling mysteries in our entire solar system. It's a puzzle that has stumped scientists for decades, and it's happening right in our cosmic backyard, on our very own star, the Sun. We all know the Sun is hot, incredibly hot. Its surface, the part we can see called the photosphere, sizzles at around 10,000 degrees Fahrenheit, or about 5,500 degrees Celsius. That's a temperature that's hard to even comprehend. Anything that gets near it would be instantly vaporized. Now, here's where things get weird. Logic tells us that if you move away from a source of heat, things should get cooler, right? If you step away from a campfire, you feel less heat. It's a fundamental principle of physics, but the Sun doesn't play by those rules. As you move away from the Sun's surface and into its atmosphere, something completely counterintuitive happens. The temperature doesn't drop. Instead, it skyrockets. The outermost layer of the Sun's atmosphere, called the corona, is a ghostly, ethereal halo of plasma that's only visible during a total solar eclipse. And this corona is unbelievably hot. How hot? We're talking temperatures of several million degrees. Let that sink in. The Sun's atmosphere is hundreds, even thousands of times hotter than its surface. This is the great cosmic paradox known as the coronal heating problem. It's like walking away from a bonfire and suddenly finding yourself engulfed in a furnace that's 1,000 times hotter. It makes no sense. The energy is coming from the Sun's core. So how can a region farther away from the core be so much hotter than the region closer to it? It defies our everyday understanding of heat transfer. For over 80 years, since the corona's extreme temperature was first discovered, the brightest minds in astrophysics have been trying to figure out what's going on. To understand the theories, we first need to appreciate the sheer scale and violence of the Sun. The Sun isn't a calm, steady ball of fire. It's a chaotic, dynamic inferno of plasma, superheated gas where electrons are stripped from their atoms. This plasma is constantly churning and boiling, driven by intense magnetic fields generated deep within the Sun's interior. These magnetic fields are the key suspects in our mystery. They are like giant, invisible rubber bands that get twisted, stretched, and tangled by the convective motions on the Sun's surface. And when these magnetic field lines get too tangled, they can snap and reconnect, releasing colossal amounts of energy. So, how does this magnetic energy heat the corona to such insane temperatures? Well, there are two main competing ideas, and the truth might be a combination of both, or something else entirely. The first theory involves something called nanoflares. Imagine the giant solar flares you've probably seen in NASA videos, massive eruptions that fling plasma into space. Now, shrink those down by 1 billion times. That's a nano. The idea is that the Sun's entire corona is constantly being peppered with an unceasing storm of these tiny, individual explosions. Each nanoflare itself is relatively small, but there are millions of them happening every single second, all over the Sun. Together, this constant, widespread crackling of magnetic energy could act like a giant distributed heater, pumping enough energy into the corona to keep it at millions of degrees. The problem is, these nanoflares are so small and fleeting that they are incredibly difficult to observe directly with our current telescopes. We see hints of their effects, but we can't get a clear picture of the full storm. The second major theory is all about waves. Not sound waves or light waves, but a special kind of magnetic wave called an alphon wave. Picture the magnetic field lines that loop out from the Sun's surface into the corona. The churning motion on the surface can shake the bases of these field lines, sending ripples and waves traveling up along them, much like flicking a rope tied to a wall. These alphavon waves carry a tremendous amount of energy from the surface up into the corona. The theory suggests that as these waves travel up into the less dense plasma of the corona, they can break or dissipate, dumping their energy into the surrounding gas and heating it up. It's like a whip crack. The energy you put into the handle travels along the whip and is released with explosive force at the tip. We have actually observed these waves with probes like NASA's Parker Solar Probe, which has flown closer to the Sun than any other spacecraft. It has detected these magnetic waves, confirming they carry enough energy to potentially heat the corona. But the exact mechanism of how that wave energy is converted into heat is still not fully understood. Does it happen gradually, or in sudden bursts? The physics is incredibly complex, so we have two leading contenders. The nanoflare theory, which is like heating a room with 1 billion tiny matches, and the wave heating theory, which is like shaking the floor to heat the air. Both theories are compelling, and both have evidence to support them. The Parker Solar Probe and the Solar Orbiter are our detectives on the case, flying through the corona itself, tasting the solar wind, and measuring the magnetic fields to try and catch the culprit in the act. These missions are providing us with unprecedented data. For instance, Parker Solar Probe discovered switchbacks, sudden S-shaped kinks in the magnetic field that could be related to how energy is released. Is this a signature of nanoflares, or the way alphon waves break? The jury is still out. Why does any of this matter? Well, solving the coronal heating problem is not just about satisfying our curiosity. The corona is the source of the solar wind. a continuous stream of charged particles that flows out from the sun and bathes all the planets, including Earth. Violent events in the corona, like coronal mass ejections, can hurl billions of tons of plasma at us, triggering geomagnetic storms that can disrupt our satellites, power grids, and communication systems. This is what we call space weather. If we can understand the fundamental physics of how the corona is heated and powered, we can get much better at predicting this dangerous space weather. It would allow us to protect our astronauts in space and safeguard the technological infrastructure we all rely on every day. So, this seemingly academic question about temperature has very real-world consequences. It's a fundamental piece of the puzzle in understanding our star, our solar system, and our place within it. Every new piece of data brings us a little closer to an answer, but for now, the sun keeps its biggest secret well hidden in its ghostly, million-degree halo. It's a beautiful reminder that even in our own solar system, there are still profound mysteries waiting to be solved. What do you think is heating the corona? Waves or nanoflores? Let me know your thoughts down in the comments. Thanks so much for watching, and if you enjoyed this journey into a cosmic mystery, be sure to like the video and subscribe for more deep dives into the wonders of our universe. See you next time.